All right, so what we're going to do is go over the notes and definitions here for 6.1, which has to do with similar triangles. So that's slightly different than congruent triangles. All right, so let's go through some terms here to review. First one is ratio. Okay, so first of all, a ratio is a comparison of two or more quantities. Okay, and we use this in math then to multiply, convert, and so on. So there are three ways to make a ratio. We can write it as a fraction, right, which is how we use to multiply. You can see it written as A to B, and the other one then it looks like this. So you'll see ratios written all these different ways, all right? And then just like fractions, if you think about it, like if I would have 6 over 8, just a reminder, it can be reduced to 3 over 4. Ratios can be simplified. The power of simplifying them is when I use them, I'm using smaller numbers, right? And I can reduce later. So let's do a quick example here. A music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, 16 trombones in stock. Write a ratio in simplest form, okay? So we'll just do 2 of these. So if I do trumpets to violins, right, we're going to use this format for this one, right? I'm comparing 40 to 24. Now, that ratio does work. I don't know if you know what number goes into both, but if I divide that by 8, do you agree that that ratio could be reduced to 5 to 3? Okay, by dividing both by 8. So that is one way to represent it. We could simplify it. Now, down here in the next section, let's talk about this again. So an extended ratio, this is a comparison of 3 or more quantities. All right, and I don't know if you can see where the 3 or more are coming from, but we're going to start with triangles, which has 3 sides, and then also in our similar shapes, we're going to start to introduce other shapes that can be similar, okay, in addition to triangles. So how would that look then again, right? We would do A to B to C, so we could do all 3. All right, now let me do one of these problems here because we do want you to be able to do this algebra here as review. Number 5 says the ratio of 2 complementary angles is 3 to 7, okay? So what we're trying to figure out is find the measure of both angles. Now, the algebra setup for this is, right? First of all, let me review the geometry part. What does complementary mean? That means 90. So what has to happen here is the same angle, or the same quantity, has to be multiplied by 3 to get the one angle, and multiplied by 7 to get the other angle, is kind of the way this gets set up, okay? Which means 3 times the quantity plus 7 times the quantity, in this case the angle, will give me 90. So that's the setup for that. I think the algebra is pretty simple here, right? I would get 10x equals 90. I would get x equals 9, okay? And then what would we do to find the two angles? We would take 3 times 9. So one of the angles is 27. Then I would take 7 times 9, which would give me an answer of 63, sorry. And then we could check it, right? They both add up to be 90. All right, just to emphasize that one more time. Let's do a triple down at the bottom. I think you'll start to see the idea. It says the ratio, so let's do number 7 here. The ratio of the measures of angles in a triangle are 4 to 7 to 9. Find the measures of the angles. So what's the thought here then? I have an angle measurement, I have an x measurement. That's multiplied by 4 to get one angle, multiplied by 7 to get another angle, and multiplied by 9 to get the other angle. And then I think we know by the triangle sum theorem, right, they add up to be 90. So what would be the setup for this? It would be 4x plus 7x plus 9x. That represents 4 times the quantity plus 7 times the quantity plus 9 times the quantity equals 180 by the triangle sum theorem. Okay, now if we add all those up, we get 20x equals 180. If we divide, right, if we divide that, I would get, again, x equals 9. That's kind of weird. The answers aren't always 9, but in that case, that's what it is. Now, if I go through here again, I take 4 times 9, right? So 4 times 9, one of the angles would be 36. I'm going to take 7 times 9. Another angle is 63. And lastly, I'm going to take 9 times 9, which is 81. So these would be the 3 angles then that meet that ratio, okay, as far as that goes. All right, let's go down here then. What is a proportion? I think you've been through this before, but let's make sure that we remember. Okay, a proportion is an equation, okay, has an equal sign, right, in between them, that states two ratios, sorry about that, sorry, two ratios are equal, okay? A proportion is written like this, right? A to B equals C to D, right? And then how do you normally solve that? I think maybe in elementary school, if they're simple, there's a way to get a common denominator. But what do we do most commonly? We cross multiply, we call it, and the means are equal to the extremes. So A times D is equal to B times C. And again, the order of those, because of the multiplication commutative property, doesn't matter. Okay. Now, when we do this, Mr. Nyes is going to show you what he means by a shortcut. All right. Now, the shortcut I always say, it might save you a little time on your calculator, is I always say if you take the cross you know divided by the cross you don't know, it's a little bit quicker. Okay, now I'll do this one out. What does this turn out to be? 4 times 7 is 28 equals 2x. I would divide by 2. I would get x equals 14. Now, if you want to make this a calculator problem, what do I mean by the cross you know? I mean the cross that has two numbers in it. So in your calculator, you could take 4 times 7 and divide by 2. So I always say the cross you know divided by the cross you don't. Now, very quickly, that all of a sudden doesn't matter when we get to the algebra. So let's look at number 13. For number 13 here, right, I got to do the two crosses, and this kind of runs out. So if I do the 1, you have to distribute. Do you remember that? So numerator and denominators are basically have parentheses. So if I do that cross for this one, you're going to get 19x minus 19 as that cross. And then the other one, if I take 13 times 6, I get 78. All right, so once you get this set up, I think it's a pretty basic algebra problem. I would add 19, divide by 19, okay? Now, one note here for the notes, just so you're aware, we do get a decimal, we're accepting that. Okay, so in that case, that would be 5.1. All right, so I think that's the basics I'd like you to know for that. We'll do some examples later. All right, so that's the basic premise here, the opening for 6-1. Okay, hopefully that makes sense. You can come with that for the next class period. We'll start to do some questions on that, and then we need to start in the next section to talk about similar polygons, starting with triangles and working our way through that.